So to classify this triangle, we're going to use both those sides and the angles. Those are our kind of two tools. We're going to start with angles. We're going to start with obtuse. Kelsey, what makes an angle obtuse?
It's more than 90 degrees.
Exactly. So if we have a triangle that has an obtuse angle, that makes the triangle obtuse. Cassie, what makes an angle a right angle?
If it has less than 90 degrees?
That's not quite it.
Wait, a right angle? If it has exactly 90 degrees.
It has exactly 90 degrees. Excellent. So to make a triangle a right angle, we have a triangle with a right angle in it. And that's it, just one 90 degree. We have right angle. And Dane, what makes an angle an acute angle?
If it's less than 90 degrees.
If it's less than 90 degrees. To make a triangle be an acute triangle, we need to have not one, but 3 acute angles. So all of the angles need to be less than 90 degrees. So I want you to all take a second and look back to the obtuse triangle and think to yourself how many acute angles there are in the obtuse triangle. Raise your hand when you have the answer. Kelsey, how many?
2.
There are 2, which means there are more acute angles than obtuse angles. We call it an obtuse triangle anyway. So we have to remember that to be an obtuse or right angle triangle, you just need 1. But to be an acute triangle, you need 3. 2 doesn't cut it. Do you guys have all this copied down? Fantastic. We're going to move on to sides. So we can also classify triangles by whether the sides of the triangle, how many of them are equal to each other. So we're going to start off and imagine there's a triangle where none of the sides are equivalent. Where this side is not the same length as this side, which is not the same length as this side. We call that a scalene triangle. Scalene. Here the words get kind of fancy. And we have a way of notating it. So when you're looking at a triangle, it's kind of hard to tell, are those lines equal? So when we're drawing, we use perpendicular lines to indicate whether or not they're equal. So if 2 lines have different numbers of perpendicular lines, they're not equal. If we move on to our isosceles triangle, that's isosceles, it is going to have 2 angles that are, two distances that are the same, which we mark by giving them the same number of perpendicular crosshashes, and 1 that is different. So this is none, this is 2 equal, and as you might guess, we also can have a triangle where all 3 of the sides are the same length. We call that an equilateral triangle. That's equilateral. To notate it, we'd give all of the sides the same number of hashes. So those are our 3 side triangle types. We also know things about the angles. So in an equilateral triangle, if you have 3 lines, you put them in a triangle. Every single time, all of the angles of that triangle are all going to be equal. They'll be exactly the same. Given that we know that a triangle has 180 degrees, think to yourself about how big each of those angles will be, and make eye contact with me when you have the answer. Great, Dane?
60?
They're going to be 60 degrees, always. How did you find that out?
I divided by 3 180.
Perfect. Yep. Great. So that's our equilateral triangle. For our scalene triangle, all of the angles are different. Use the same notation system of different numbers of crosshashes. For our isosceles triangle, 2 of the angles are the same. And 1 of them is different. We can think of it like a triangle, as many sides as it has equal, it has angles equal. So an equilateral, 3 sides, 3 angles. Isosceles, 2 sides, 2 angles. Scalene, no sides, no angles. So those are our 6 different triangle types. When we're classifying triangles, we can put them together. Now we get to do our triangle chant, which we all know, so let's give ourselves a beat. And here we go.
Triangle, what's your angle? Are you big and obtuse? Are you small and acute? Are you square and right? Triangle, what's your side? All equal,
Equilateral,
2 equal, isosceles, none equal, sad scalene.
Excellent, you guys rock.